Hi there and welcome back to Tripplikit and part 5 of our investigation into building triplicate priced PCBs using KiCad and PCB Way in China, and the boards are due anytime now, but before they arrive we'll get on and order some parts, and for that we need to generate a bill of materials. So without further ado, let's do that. Okay, so the first step on getting together a bill of materials is getting together a list of parts, and KiCad conveniently allows us to edit symbol fields, that button says. So if we were to do that, we get a list of parts, and we'll extend that. Okay, so let's turn that off for now. So there we go, that's a list of our parts, and we have the reference, the value, the footprint and the quantity. So we want to add, well, I think we want to add the manufacturer part number, and since I should be ordering them from Farnell, just because that's where I'm used to going for parts, we want a Farnell part number, because if we have a list of Farnell part numbers and quantities, we can just paste them straight onto the website and it'll generate our order for them, which is a lot quicker than typing in part numbers or finding the parts on the website. So should we, I don't know what the difference between, oh yes, we can actually update a footprint from here and then apply it to the schematic, but we're not going to. So we then need to take each part. So what should we start with? We'll start with the MOSFET. Properties, edit properties, and we want to add a field which we will call manufacturer, which is manufacturer part number, but we know what that means, don't we? And for that particular transistor, I actually have, okay, from doing it on Veriboard, I had on Notepad a little list of the parts I'd ordered. So for the transistor, so there we are. That's the part number. So I shall copy that into there. We don't need to check, we're not going to display it ever. Hit OK, and look at this again, and there we have manufacturer, and the manufacturer part number appears for that. Okay, so far so good. So we will add also for that no, hang on, plus Farnell. What have I done there? It's a mark on the screen. Should keep my screen cleaner. Let's go back into here. What's the Farnell number? That. Okay. Look at that, and we have Farnell manufacturer And those are all the extra fields we want to create for now. So I am going to fill these two columns in for the rest of the components, and then we can reconvene. So okay, I am going to use this to update the values in the components, because it's got a clever feature. You can group symbols by value. So C1, C3 and C6 are all 100 nanofarads, and then D2, D1, D2 and D5 are all 4001, and I'm assuming everything of the same value is the same component. It is possible to have like a 100 ohm 8th watt resistor and a 100 ohm 5 watt resistor on the same design, but this is not the case in here. So I can group them, group symbols, group by value. So I only need to enter these two once here, and then if I do apply save schematic and continue, it will update all the components. Instead of having to update C1 and C3 to C6 individually, I can do them all as one. Shall we have a look? Shall we have a look? So we'll go to our little notepad listing. Okay, the capacitors, here we go, multi-layer ceramic capacitors. That is the part number. Go back to this, that is the Farnell number. So C1. And if we apply save and continue, have I done that? I will see. So C1, which is that, just press D there, yeah, it has the Farnell and the manufacturer filled in, and C6, which is there, has it in. So that's good, nice. That's nice and quick way of doing it. I like it. So I will carry on and fill all these in like that, and then we will reconvene. So here we are, we're all done. A couple of things. Now the heatsink has two little pins which go through the PCB and solder down to hold the heatsink to the PCB, so I should have made a component with those two pads on, but I didn't. I just used two pads and drew an outline, and those are the two pads. So that leaves the heatsink and the mounting kit to attach the transistor to the heatsink and insulate it, which are on the BOM but don't have footprints, and that in KiCad is a bit of a tricky thing to do. So pro tem, I have just added them to these two sets of pin headers, because they're not actually pin headers. The pin header of the board, the USB and the SD card boards, are going to be soldered straight through these holes, so they have no actual component in them. And so I've just tacked the heatsink and the insulating kit on there. So now that then is the parts list. Very nice, and very cleverly, if we group symbols by value, then we get a bill of materials. So all we need to do now is output that to a CSV, load it into a spreadsheet editor, fiddle the columns and to be what we want, and we could drop that onto Farnell's website and order the parts. But unfortunately this does not have a nice output to CSV button. We have to go into the dedicated BOM creator. Now this takes an XML file, and these are all just XML style sheets which turn that into files of various formats. And if you really want to edit XML style sheets, you could make your own, but I personally don't want to edit XML style sheets. I want to do something interesting. So that should be BOM2CSV, which should output to those fields. This, I guess, is just a little information on what it does. So should we try that? It doesn't like the arguments. Okay, should we try that one? That one doesn't like the arguments either. BOM CSV grouped by value. Let's try that one. That one's worked. So shall we look in our folder, PCB back charger, and we should have well, there's a CSV there, and we will attempt to open that. Okay. Okay, that is actually a parts list. I wonder if these will any of these will generate as a BOM. I will actually turn you off and see if that is going to happen. Okay, so it turns out this is actually the best one, and I didn't, when I first looked at it, scroll down and find collated components, which is what I want. We get a quantity there and a Farnell number there, which is all we want to place our order. So we're laughing, I just need to do some manipulation of this and I can go away and order some parts, which I will do. And I received a message back saying my circuit boards are on their way, taking 3 to 5 days. That's why I pay $28 postage, because they fly them over. So I will order some parts, and we will reconvene when we have some circuit boards and some parts. Okay, so we have some deliveries. We have from Farnell some bags of components, and from the Far East we have some PCBs, I assume anyway. So shall we see what we've got? Okay, quick look at what's in here. I shall check them off on camera. Paperwork, and there we go, heat sink, LEDs, power resistor, and some capacitors. In here we have more paperwork. What's this? Some resistors. Don't know. All wrapped in bubble wrap. More resistors. More resistors. More resistors. LEDs again. Transistors. More resistors. More resistors. Right. Well, I shall, as I say, check those off camera. In the meantime, let's have a look at what we've got in here. paperwork. And a cardboard box. Right, it's only enough to get us in, it should be. And there they are. See if we can zoom in. So yeah, they look the business. I guess we should try and build one up. Okay, so on the previous video where I sent the boards off for production, I'd carefully made the longest dimension of my board just under 100mm so that it came in at the lower price, and their reading of the Gerbers here came up with it as 101.8. So I contacted PCB Way to see what they had to say about this. And here are the message. So yeah, I just said basically, do you have any idea why this difference has occurred? So I got a message back. Hello, good day. We measure the size according to your Gerber file. Yes, I've checked my Gerber file and it is just under 100. I have checked your Gerber file. May, because of the outline is thick, measure the size will little different. Please kindly check. Thanks. Okay, so they think my Gerber file outline is thick, which is causing the difference. So should we have a look at that? Okay, so here we are in the Gerber Viewer, and we've got our little measurement tool up and running. So let us see what we think our Gerber measures. Now we go on along here. There we go. 9.94. And let's, for which we'll use in a minute or two, let's also see if we can measure the copper pore size, which is 90. There we go. Okay, 97.44, nearly 98. And if we zoom in, the thickness of our outline is 0.11mm, and I know it's set at 0.15, so that's not that thick. So let's actually see what our board measures. Okay, so all I've done is plonk the board in the scanner with a ruler, so we can make some accurate-ish measurements of how big the board is. So if we zoom in at the bottom end of the board, we can see, okay, you can see I've just drawn some rectangles using good old Windows Paint, and we can see that the bottom edge of the board is at 20.7mm. The bottom of the copper pore is at 20.6mm. I've used a bit of pixel counting to try and improve the accuracy here, which is how I can claim to be anything like 1/10 of a millimeter. And at the top of the board, the top of the copper pore is 119.7mm, and the top of the board is 120.7 millimeters. That gives the board length to be 120.7 minus 20.7 equals 100 exactly, and the copper pore to be 119.7 minus 21.6, which is 98.1 millimeters, which is near enough. So we conclude that the board is the size we want it. So I think what is happening is that as far as PC Way are concerned, they consider the board size to be the amount of PCB they use to make it, which is the board size plus the width of the saw blade or whatever they cut it with all the way around. So I guess that's problem solved. And finally, if you want a proper tutorial on KiCad rather than me trying to work it out as I go along and going on a lot, these are good. John's Basement, and I did sort of dip into a few of these when I got stuck making this series of videos, so I can recommend them. So there you go, John's Basement, and he calls it KiCad, so I think as of now I'm going to call it KiCad. So for now, that's it. So I'm going to end this video here, and next time we're going to build our circuit up. So if you like these videos, please subscribe, thumbs up, comment, and for now it's goodbye from Tripplikit, home of interesting electronics. Goodbye.